So Shaila sees her slides, you see her slides, nobody else sees her slides. Your slides are still there. Ah, you see your slides, nobody else sees your slides. So our first presenter, eventually, is Shaila from is it Prime Bank? Yes, Prime Bank in Bangladesh. She has signed her zone because I've bullied her into it. So I should call out that .bd has been signed for a very long time, but the SLDs, com.bd, net.bd, ac.bd, etc. have not been signed or not usefully signed until very recently. So that happened, what, May last year? September last year. All right. Yeah. There's some slides. Hooray! And they're gone again. Take it away, Shaila.
Thank you so much, Philip. Extremely sorry for the technical difficulties. I'm Shaila. I'm working as a system, I'm taking care of the system security for Prime Bank PLC. It's a local Bangladeshi bank. And I know you just had lunch and you might be feeling sleepy, so I will keep it light as much as possible. And today I'm going to share our journey, DNS implementation journey, which we did last year in October. And it just I was very much happy about it, and we were very much happy about it, and we wanted to share about it with the community. So, as we work for bank, it is very much important for us that our customer and the users who are using bank domains, they go to the authenticated website. Because some customer, they want to go to primebank.com.bd, it is easily can be redirected to some other malicious site. So we were actually planning to do DNSSEC for a long time, but we was not able to do it because Philip just said .bd was originally signed back on 2022, but afterward the SLDs, .com.bd, .gov.bd, those were not signed. So technically we didn't enjoy the benefits of signing the DNSSEC back on that time. So suddenly they decided on last year that they are going to do it, and we were the first Bangladeshi bank among 61 others that we decided to jump for it, and we implemented it within 2 months. So we wanted to implement DNSSEC because it gives a chain of trust, because we have signed it in our domain, then it is also it has trust with .com.bd, then it has a trust chain with .bd, and on top of it the root. So this is a trust chain we wanted to maintain, and that's why we went for it. So there are some of the examples. I'm sure I couldn't manage to put it in one slide, but these are some of the notable incidents that happened in last 1 decade. Especially there was a Brazilian bank back in 2016 that were their domains, all their domains were hacked for almost 5 hours, and all their customers were redirected to a malicious site. So this is one of the incident, and also there was another incident like My Ether channel DNS incident, My Ether channel related incident. My Ether channel was not breached. Okay, My Ether channel was not actually breached, but there was a very classic significant attack where like the DNS routing, the three core protocols like DNS routing, TLS and BGP routing, DNS and TLS, all three of them was manipulated to conduct this attack. So this kind of attack not maybe fully preventable, but it can be minimized. It can be minimized by DNSSEC. So considering all this, we decided to go for it. So this is this is the statistics that I had created back on November. This is just Bangladeshi statistics, but still I'm going to give an overview because like it's more or less the same for all the countries, all the states. And in Bangladesh there is 61 banks, and you can see that in the private commercial bank only one bank till now we have like we have signed DNSSEC, and there is another foreign bank who have signed DNSSEC. So among all the 61 banks, there is only one, there is only two. So there is actually pretty much scope for update and awareness. So why DNSSEC is important for critical infrastructure and financial organization? We already all know about it, because it helps to prevent the DNS hijacking and cache poisoning attacks, and also it reduces fraud and credential theft, and especially for the banks, everything depends on customer trust. So we don't want to damage our reputation, and we want to prevent all the brand and reputational damage kind of thing. So before starting telling our stories, I just wanted to share like Prime Bank finally configured their DNSSEC in back on 8 October. And we were happy, but still there are some factors that have that we always keep that in our mind. Like it only will work if the recursive resolvers validate. Okay, it only will work if the recursive resolvers will validate. So these are some of the this is the screenshot that we had taken just 2 months back. Before signing our domain, and you can see from the screenshot that the .bd domain was signed, DNSSEC signed, but the .com.bd, there is no DS record or DNS key record. So it's just 2 months back, taken at August. And of course for primebank.com.bd, there was no DNS key and DS record. And like afterward in October, we have actually 3 domains. So these are the screenshot for all these 3 domains. You can see all greens, which means like we have signed, there is DNS key and also DS record for the primebank.com.bd and two other domains that we have. And also you can see the trust chain is properly built. The .com.bd is also signed, so everything is green. And when we started planning, before we start implementing it, it was the most important phase that we have discussed with our registrar and like all the experts, like especially like Epinic help us a lot regarding this. And we have discussed with them like what should be our approach, what should be the parameters that we have taken, what are the other deployment examples. And then we actually decided as we have like F5 big IP DNS in our infrastructure, and we already had configured an authoritative DNS in it. So it was not that much harder for us to adopt the DNSSEC. So we started planning for it, and we made the strategy. And first we decided like what would be the ZSK strategy, like ZSK rollover strategy. We took it pre-publish method. And for the KSK rollover strategy, we took double signing method. And The key parameters, first we actually enable the DNSSEC in DNS profile in our DNS server, and next we actually generated the ZSK and KSK using the algorithm that was recommended by BTCL and also EPINIC. And the ZSK, for the ZSK we actually, the TTL value is 1 day. You can see that for ZSK and KSK both we are using algorithm 13, ECDSA P256 with SHA-256, and the TTL value is 1 day, and the signature validity for both is 7 days. And for ZSK, you can see the rollover period is a little bit less, which is 45 days, and the expiry date is 90 days. For the KSK, the rollover days is 1 year, and the expiry date we chosen 7/30. It was like more convenient for us, so that's why like we choose it. So once the ZSK and KSK was created, the next step was to create DNSSEC sign for the primebank.com.bd and some other domains we have, like 2 other domains with those keys. So using algorithm 13 by BTCL recommendation, we actually had, we can see like from the screenshot you can see there are still some deployments using RSA, but for new deployments, we have chosen algorithm 13 over RSA, because RSA is no longer recommended for new deployment on DNSSEC signing by RFC 8624. Because like it creates algorithm 13, it gives better performance and smaller signatures. Also for the DS digest type, we have chosen SHA-2. We have chosen SHA-2 for strong security over SHA-1. So then we exported the DS record, and we have uploaded it in the BTCL portal, and the parameters that were required to enter was the key tag, which is randomly generated, the algorithm, the digest type 2. Digest type 2 means SHA-256, and the digest itself. So this is the screenshot where you can see like we had input it into our BTCL portal for .com.bd domains. And there's another screenshot for our another domain, which was Remit Prime. We have gave it import into another domain which is not bought from BTCL. And also like this is very important, like we wanted to make sure that everything is following the best practice and recommendation. So we configured DNSSEC parameter 100 that is recommended by RFC 9276. And this DNSSEC and NSEC 3 proof of non-existence is configured to prevent the zone walking and authenticate and authenticated denial of existence. So if anybody wants to get reply for fake123 at fake123.primebank.com.bd, which domain doesn't exist, they will not get any reply. They will just get a reply with a hash value with digital signature on it that it doesn't exist. So we have ensured that. These are some of the verification process. You can see like we have checked the DS record, it already propagated in the parent zone. So when we dig with this command, we can see that DS record has been propagated. Also we check the DNS key records, which is visible in this second output. We can see that KSK record is present, 2 JSK record is present also, following by RRC signatures. And just to make sure that we are following the current best practice, we have also checked the ICANN kind DNS practice guideline, and we have checked all the points. There was like 6 points for that is like applicable for our case. And like we have like the practice one, you can see that we have configured DNSSEC for all our domains, and the key management is followed the best practice. So like we have checked the practice one, and for the practice two, you can see the zone transfer between the authoritative server is restricted. We made sure the zone transfer is only restricted with the secondary server. And for the practice 3, we ensured that all the zone files integrity are regularly checked and monitored. For the practice 4, we are in our organization, we are only running the authoritative DNS. So we have dedicated server for authoritative DNS. There is no recursive resolver is configured over there. So we have complied the practice 4 as well. And we have 2 DNS server currently, both are in DC and both are in separate server, but we are still planning for another server that will be tertiary server that will implement in the DR. And also, like for the practice 6, the infrastructure that servers are my DNS service is actively monitored. Definitely, we are continuously monitoring all our servers. So the challenges we faced, I'm sure like this is the most exciting slide, but fortunately we have not faced much challenges, because like before implementing it, we took a quite long time for preparing it. We actually thought like what can go wrong, and we also have talked with our friends from outside country and like some experienced expert that okay, what we may face. But the main challenges we faced was the convincing the management to enable DNSSEC, because it was something unknown to them, and they were asking like, okay, 60 other banks, they haven't deployed DNSSEC. Why do you want to deploy DNSSEC? This might cause any problem. So we don't want to face any problem. So we had to ensure that, okay, if we do it properly, we are not going to face any problem. And also there was staff skill shortage and knowledge. And thankfully, BTCL and APNIC has helped us a lot during the process. And also another thing, initially we actually had considered to implement an external HSM, to manage the DNS keys, but it was not later pursued because of additional cost. And another problem, another challenges that we have like identified and we have discussed about it, that is the thing. The thing is the dependency on a parent zone. What it is, the BD.BD registry dashboard show only one DS record entry right now, and which will create a confusion on parallel DS publication during KSK rollover and increasing operational risk. So when we talked about it with them, they said like they are like they have noticed it and they will like implement it in very soon. So some of the takeaways, definitely DNS is a very old technology. It was not originally designed for strong security. That's why we actually have to follow all the best practices, and we have to know what is the like what is the best practice right now everyone is following, and also like if possible we have to deploy DNSSEC. And deploying DNSSEC in large organization can be challenging, but it is achievable with proper planning like we did. And also DNSSEC is more than like signing records. It requires preparation, cleanup, migration, and continuous monitoring. So we have been continuously monitoring this. And automation is essential, of course, automating the signing and key rollover, that is reducing human error. So all our JDSK and KSK keys that are like that are generating automatically, just only the DS record, we have to manually submit it on the portal. And this is one of the statistics. This is the statistics of DNSSEC validation in Asia. You can see it. You can see here. Previously I said like we have configured DNSSEC for our domains. That's very like exciting thing for us. But if the ISPs, if the DNS resolvers, they don't validate it, then it doesn't have any meaning. So like we were checking that if most of the Bangladeshi resolver, they are doing it or not. Also we have customer outside Bangladesh throughout all the Asia Pacific and also some of the Middle East countries. So we are checking like if this DNSSEC is going to bring us some fruitful result. So we checked it and we found that like in Southeastern Asia, you can see in Thailand, the DNSSEC validation rate is very low. which is 14%. And in Indonesia, the DNSSEC validation rate is 25.23%. And in Philippines, it has the highest rate for Southeastern Asia, which is 92.38%. And for the South Asia, the Bhutan has the highest number, which is 95.10%. And in Pakistan, it's the second highest, which is 92.01%. And in Bangladesh, that is, I felt like it's an acceptable number, which is 82.26%. So I am hoping that it's going to be fruitful for us, at least for Bangladeshi people. And these are some of the useful links you can see. And questions. I kept it very short.
5 minutes for questions.
Two questions. I think it's on? Yeah, it's on. Two questions, or at least one comment and one question. Comment, if you haven't used DNSViz.net, you should. It's a really good way of looking
Yes.
at your DNSSEC validation chain, and if there are issues, DNSViz does expose them really cleanly.
Yes, we have checked it.
Well, you had a screen that said I checked it manually, and I'm kind of going, DNSViz would have done all this.
Okay.
Secondly, you're running two zone signing keys, so every entry in your zone currently has two RRSIG entries.
Mm.
Are you rolling the key right now?
Like it's already generated, like after 45 days.
So you're in the middle of a key roll of
Yeah,
your
yeah,
zone
exactly,
signing key.
exactly.
Why do you need 45 days?
Because we actually thought like pre-published method is going to be better for us.
You're not the root zone. You're
Okay.
down a level.
Okay.
You can make this a lot faster because it depends on cached record entries in folk out there in recursive resolvers. You don't need to have large entries when you're rolling your ZSK. You can make that a lot quicker. That's all.
Thank you.
I'll take the longest route.
Hi, my name is Sergey. For generating and storing the keys, you have selected the hardware security model. So probably the most expensive way to store the keys. I understand this is the bank, and if you have a physical safe, it's probably could be seen like a best way to store the keys. But have you considered other software, the software way to store the keys, like OpenHSM or so?
We actually are still exploring because like when we actually discarded the HSM option, then we had consulted as we have configured authoritative at F5. They said like they are keeping it in their internal storage database and we cannot extract it from there. So they ensured us like a lot of organizations are using their infrastructure to store the keys. So in that way it is pretty secure, at least for our organization. Thank you.
Hello, Nishal Govardhan, Packet Clearinghouse. Congratulations, firstly.
Thank you.
Well done. I'm curious about, I mean, we all understand, I think most of us here understand the value of DNSSEC and we understand why it's necessary, the safety aspects, etc. So my question isn't really a technical one, it's more about policy. Are there policy initiatives inside your country? And I apologize, I don't know that much about Bangladesh, but are there policy initiatives inside your country and a region to promote the signing of important infrastructure, like banks? I ask this because we've been doing work in a few other areas. And for example, Saudi Arabia now has a directive that says all banks need to be signed by, I think it's the end of 2027. So are there similar things? And do you think that that sort of thing would be welcomed by industry?
You know, your question just made me smile. You know, there is a reason, like, why I'm happy to get your question. Like, even like 2-3 years back, we were not that much aware about it and we were not feeling like we need it. But nowadays, at least for the banks, we are getting a lot of attacks, a lot of compromise chances. So what happened, like when we implemented the DNSSEC, right after 2 weeks, the Central Bank of Bangladesh, their whole CERT team, they came to visit us. And they gone through it and they asked like what are the challenges if we instruct other banks to implement it, what could be go wrong, or like is there any like costing related to it. So they heard about everything, and we had a 4 hours long session regarding this DNSSEC. So like they went back, and initially now they are preparing to do DNSSEC for their domain for Central Bank of Bangladesh. And they're saying like in next year maybe in 2027, they will start telling all other banks that if possible they should start doing the DNSSEC. And I'm sure like as BTCL already have configured it, maybe BTRC, our central governance for telecommunication, they are also preparing some guidelines, things are changing. So I'm sure like it will be exclusively included into the guidelines that like, okay, if you are capable and if you think there is not much risk, you can handle it, you can actually configure. But yes, for banks, I can ensure that within like the next 2 or 3 years, we will see more and more banks are coming in Bangladesh, like they are doing DNSSEC. Thank you.
I'll hold you to that. We have time for maybe one more question, or we can give Jeff 1 more minute. All right. Thank you, Shaila. Thanks very much. Very insightful. Our next speaker is Jeff Houston. And I can't remember which of his talks we accepted, so I'll peek at the title. This one. We accepted to talk about DNS resolvers and name servers and Indonesia. Jeff, go for it.
Thank you. Good afternoon, all. I'm doing a clicker. Do something and make the clicker work, please. A dongle needs to be installed. Thank you. It went bzzz. Yeah, right, we're doing the clicking thing. Oh, the mouse is working. Thank you. Okay. This is actually an investigation into the guts of the DNS. And I need to read this too because I haven't seen it for a few weeks. Those questions are kind of interesting because there's a certain amount of folklore. When you stand up a domain name, how many authoritative servers do you use? If you're the root zone, there are 13 names. But not many folk use 13. Is 1 enough? Oh, come on, you're in a DNS room. What's the answer? No, 1's not enough. We always have at least 2. Well, yeah. How about 3? How about 4? What's the right answer? If we're trying to maximize performance and resilience, there's 2 different things. I want the answers quickly, and for everyone who might be asking a question, and resilience, if 1's not available, I want something else to plug the gap. So how do we maximize that? And lastly, how's Indonesia doing? How's the DNS resolver infrastructure and effectively authoritative servers for Indonesian domain names, how are they doing? So there have been a number of papers about this. I call this recent-ish because it really is 9 years old, but it's actually quite a good study. John Hardiman and folk from SDN looked at these questions and put out a paper on this. And oddly enough, that conclusion is kind of interesting, but difficult. All name servers in a DNS service need to be consistently provisioned with, quote, reasonable anycast. And oddly enough, reasonable anycast can sometimes, for you and me, particularly if it's your personal domain name, be quite a challenging issue if you want to build it yourself. More recently, October 24, there's no standardized way that recursive resolvers query authoritatives. True. It's not part of any standard. And we've done the work, say Zhang Lu, Song and Hook, Shimon Hook, that we've gone and looked at a few of them and see the way they work. So this is a good thing. So let's have a look at some standards, and I love this. We didn't write RFCs the way we write them today, because in RFC 1034, which was written at about the year dot, what we have to do is sort the name servers according to their batting average. I'm not American. I have no idea what that word means. I think it's something to do with baseball, and someone else might say, what's a batting average in the DNS? So let's do a little bit of testing and start wandering around in this concept. So I set up a domain myself with 4 unicast authoritative name servers, and I had client systems query them using unique names. So I'm not doing caching. Caching is evil in this, and I'm tracking who does what. So here's a map of the world. I have a server in Singapore, Mumbai, Frankfurt, and Atlanta. There's some delays there from a testing point where I live in Canberra. And as you can see, they're all wildly different. Now, in theory, all my queries from Canberra should go to Singapore. Why? It's closest by delay. It's the fastest one to answer. And what I'm expecting to see, if my recursive resolver is well behaved, oh, this should be a pointer. Most of the time, I latch to Singapore because it's the fastest. Push the button and move the, oh God, so slow. But every once in a little while, my recursive resolver should go, anything changed? Let me check the other 3. So I'm expecting that. Yeah? What do I see? Bind 9. Sort of okay. It's sort of latching to Singapore. It kind of is keen on India. I don't know why. EU and America, sort of there. It's not completely uniform, and it doesn't sort of do it regularly, whereas I'm querying regularly, but it's probably good enough. Unbound. Oh, these guys are bonkers. No, they are. They're latching somewhere between America and India. America is furthest away. And they're kind of not asking Europe at all. Why? Is Unbound that broken? Yes. Unbound is that broken. Google. Now, this is interesting. Google doesn't seem to latch. And there are probably reasons. There's a slight preference to Singapore, but I'm only querying once a second, and to make an impact on the local Google engine, I need to query once every nanosecond or faster. I need to give it a blitz of queries, and then I'll go, right, you're important, I'll do something. Once a second is kind of, don't care about you. So interestingly, Google displays the query load everywhere. Cloudflare, it's hard to say if it prefers India over Singapore, but I think it does. And again, it's a busy name server. It actually doesn't do a good job of optimizing where it asks on a cache miss. Interesting. Not what I would have thought. So that study is right. There is no common behavior amongst recursive resolvers. You might think you've done a really good job in spreading your authoritatives around the network and hope that folk go to the closest, but they don't. And it's kind of interesting when you look at the errors, what units of time are involved. So let's move away from my desktop and start really churning this up. 25 million experiments a day. So I'm using Google Ads. Thank you, Google. This is a really cool approach with ads. And I am hammering at this from people all over the world to the same 4 servers. And I'm trying to look at, do they pick their closest? What's the interaction? So again, Atlanta, Frankfurt, Mumbai, and Singapore, we can see the kind of preference points and delays. And here's a resolver running in India. Let's go back. Can I go back? There is a server in Mumbai. It's really close. Whatever. There's one in Frankfurt. That's a long way away. Atlanta, Singapore, you'd think it'd be close, but it's not really. Networks. It doesn't like America. It really doesn't like America. Now, this is a huge number of queries, and it's going, I'm not going to check on them. But of the other 3, they're all the same. They're not. There's a huge performance difference, but this resolver in Bharti Airtel kind of goes, nah, don't care. Even across 12 hours, it asked America twice. You got any closer? Nah, continental drift, kid. It's not going to move. But Singapore, Europe, what is going on? This is really quite weird. And if I do it for one whole week, and I start looking at attachment time, because in theory, I've got these 4 candidates, I should find the fastest one and go, okay, for the next X seconds, you're it. You get all my queries. And then I kind of go, has anything changed? Let me poll the other 3. So what I find is it should attach to Mumbai. It doesn't. Its preference is Frankfurt in Germany. But I'm in India. Yeah, right. Sucks to be you. This is bizarre. Let's take the largest 100 recursive resolvers on the planet that have the most users according to Google Ads. And we look at attachment points. This thing here, the bigger the circle, right, the more it's getting a preference. Each vertical line is 1 resolver, and in theory, there should be a strong preference because I've spaced these out. They're not equidistant. There's always going to be a favourite. Okay, that's IP addresses, and it's kind of, this is all wrong. Of those most active, you should be latching for about 60% of the time. Only 53 out of those thousands show none, but no attachment preference, it's not very good. So, are they good at attaching to the closest? What's the error? Here's something operated by this number 2 provider in France, Free.fr. And if you sit inside France and look at my 4 servers, Atlanta 95 milliseconds away, Singapore, whoa, on the other side of the world, 307. Frankfurt, now it is German, and these are French. So they might have taken that 9.8 milliseconds and multiplied it by 10,000, who knows, but you know, it is the closest, truly, really. And Mumbai, a bit like Singapore, is a long, 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 long way away, but it prefers America. 70% of the time, this particular resolver shows attachment to America, and it's kind of, this is weird. It really doesn't work very well. So I have 661 recursive resolvers, 498 responded to ping, the others don't because ping is evil, we all know that. Of those 498, less than half chose the server that was really closest by delay. Less than half. The others made a dud choice. 299 chose a server that was more distant. And the additional delay wasn't a millisecond or 2, it was 142 milliseconds. Now, if you're in the browser world and you really want to shave milliseconds off click to screen, all that kind of stuff, milliseconds count. If you're in the DNS, tenth of a second, whatever, don't care. 142 milliseconds, oh, it's about the same, isn't it? Here's the mismatch time distribution. And there's this sort of steady thing around 100 to 140 milliseconds where folk are going, it's the same number. It's not. How far around the world can you go in 100 milliseconds? At least a third of the way around the planet. They're going, nah, it's the same thing. A strong time mismatch, which is actually quite bad. So you might take a lot of time and attention to carefully choose a set of authoritative name servers that are well balanced around the world, that sort of cover populations in Europe, populations in America, etc. And the DNS goes, fascinating, glad you spent that time and effort, I don't care. I really, really, really don't care. You're doing a great job, but it goes, no. So they don't make an accurate selection. All that work is wasted effort. Any potential performance benefits don't come, and the granularity is 150 milliseconds. I went and asked the folk at Unbound, and they said, we have a minimum level. If it's 140 milliseconds or less, it's the same. I'm sorry, excuse me, I'm in Australia. Well, any machine in the Pacific, bits of America, it's all the same to us. We just don't care. I thought, wow, I thought you cared about delay and performance. We don't. We really don't. We'll just send the packets anywhere. I say, let's go back to Indonesia, and let's have because I've just got a few more seconds, haven't I? Let's have a look at Indonesia. Good on you. In Africa, for reasons that are Africa, if you're in, say, the Central African Republic, you send all your queries to Google. DNS is hard, they're really good at it, I don't know. If you're in Indonesia, oddly enough, most users, 75%, actually use their local ISP. And it's kind of, well, that's a really good thing. It's local, I don't have to configure, well done you. Google, oh, between 10 and 20% of users in Indonesia use Google. Interesting. Cloudflare, about 4%, 2%. OpenDNS is still a thing. I thought it was dead. They're still around. And is someone here from Quad 9? Good. We can see you. In terms of market share in Indonesia, I'd say it's modest. It's the best way of describing it. It is visible, but it's not big. So Google is pretty competent, pretty big. But let's sort of look at this again, and I take the top recursive resolvers that users actually use. Now again, this way this works is the top line is, God, Europe, the next one is India, the next one's America, and the bottom line is Singapore. Singapore, you could swim to Singapore from here. I'm like, it's not very far. It's a bit of a swim, but you'll get there, right? It's close. And so this is kind of obvious, except for 1, 2, 3, 4, 5 anomalies that go, nah. America's closer. It's not. This is weird. I have their IP addresses. Do I have their domain names? Yeah, I have their domain names. Go and look at the slide pack, but you'll see that, it's too small. Go to the PDF, blow it up, you'll find the folk who just haven't got a clue. That's the cumulative distribution in the red bars. So most folk are doing the right thing, but some aren't. Per AS, yeah. Yeah, because, I can. I have this network. I'm going to use it. Packets, distance, don't care. This is actually now per AS, not per individual IP address. So all those resolvers behind Telekomunikasi Indonesia, the PTT, is all just one. And in a bigger view of the world, you actually see a fair deal of leakage moving to other areas. And this is the fact that if you're using Unbound, for example, as we said before, it doesn't know or care. Why am I stressing this? Someone here works in the FreeBSD project, don't they? As you see, it will get better eventually. It won't. Sorry. So recursive resolvers actually do a decent job. It's better than the forwarding average of a lot of the world, but there are still some pretty sort of rabbity, weird areas out there. So how should you do it? Unicast is the wrong answer because recursive resolvers just get terribly confused. Relying on the DNS to pick the best server is not a good idea. So maybe Anycast. Well, who uses Anycast? Well, the root zone uses Anycast like crazy. And in actual fact, if I look at all the top level domains, the root uses Anycast with 13 name servers, but the two numbers that are popular at top level domain names are 4 name servers and 6 name servers. 5 name servers is evil. Evil. You will break the DNS. Well, that's what these folk think. I have no bloody idea. As far as I can see, there's no difference between, 3 and 7, to be perfectly frank, but, 4 and 6 are magic numbers. How many of those are carried on Anycast? Well, again, I try and unravel Anycast and see what I can find. At the top level domain space, Unicast isn't that common. 587 names out of 10,000. Sort of, okay, few. A whole bunch use what I call limited Anycast. I have a server in Paris and a server in Frankfurt. That's Anycast, isn't it? No, it's not. It really isn't. And so this is kind of, if the round trip time variance is less than that magic 150 milliseconds, you're not really serving everyone. You're almost like a unicast in a small area of the globe. If I've got Anycast to the point that almost anyone in the world can get to you within 150 milliseconds, including South America, that's good. How many folk are good? About a quarter. So good DNS is actually harder to find than you might think. Only Unicast, 8 TLDs, Mix 378, and Anycast, well, you've just seen those numbers. Diverse Anycast, 289 out of that. So, yeah, reasonable scorecard. AS diversity, how many ASs serve your DNS? Well, oddly enough, 5 is a better number. It's not so evil, but 1 is evil. 2 separate resolvers, 2 separate ASs, 2 separate networks for your authoritative server, that's the most popular answer. So most of the time you use 2 different ones. How about in Indonesia? Much the same. 2 is the magic number. So out of the Tranco top 1 million, pulling out the ID domains, we find a reasonable amount of diversity and a reasonable amount of engineering. Nothing spectacular, but nothing terribly bad. What about the ID domain names themselves? Mapping that to the IP addresses, because each IP address serves in a whole number of domains. The number of IP addresses, 12 is 1,800 are served by 12 IP addresses. It's a waste of time. How many IP addresses will you try before you say, I give up? 12? Nah, your resolver isn't that obsessive compulsive. After about 5, and certainly after 7 seconds, it goes, this is boring. Serve fail, go somewhere else. So there's a lot of engineering going on here for no purpose. AS domains, who is used by Indonesian names? Cloudflare is free. Cloudflare is really popular. 44% of all .id domains are on Cloudflare. What a surprise. Akamai DigitalOcean, you can read that as well as I can. But, you know, free dominates. What a surprise. So, where am I coming? And I think I'm in time, right? Good. DNS is a lousy load balancer. Don't use it. Unicast distribution of authoritative name servers is a waste of everyone's time and money, including yours. Walk away. So don't bother. Anycast is actually really quite cool, but doing it yourself is a waste of time and money. I am not going to endorse Cloudflare, but let me say it's a bloody good Anycast network and you don't pay them a cent. Wow. And they're good at what they do in that respect. If there's other people that do it for free in that world, go and use them instead. But, you know, that's kind of what you want. A highly diverse, low-cost, authoritative server network. Multiple Anycast services is even better, sort of. But if you're DNSSEC signed, OBank in Bangladesh, be really careful about the way you promulgate DNSSEC information, because what you don't want is someone traversing the tree and getting different information as the keys roll. So at that point you might need longer roll times. 5, 6, 7 separate service providers, your brain is going to explode, as with your DNS. Don't do it. 2's a good number, 3's okay, any more than that is just going to hurt. Questions? Because that was what I found. Yes, question up the back there.
Yep. We've got time for about 2 questions.
Hi, Joss.
Hi.
Actually, it's not a question. So maybe something like your data, 70% that Indonesian ISP is using their own
Using their own ISP's resolver.
resolver. That is because the government is blocking. There's a rule from the government that must be used.
Okay, so the real reason is that most of us, particularly on mobile phones, never play with the settings. So you can go to almost any ISP on the planet and find between 60 and 80% of users just go to whatever the ISP does. And you go, well, what's the rest? Interestingly, we find that the use of non-ISP resolvers is highest on weekdays and lower on weekends. What does that say? Enterprise customers don't trust ISPs, they build their own, and where do they go? They tend to head towards the big open ones. So they tend to head to Google and Cloudflare or whatever to back up what they're doing inside their enterprise network. So the only folk who twiddle with the buttons are actually folk who, in theory, you're paying to know what they're doing.
Yeah, but the government is have the policy that we must use their using their blacklist, the RPC zone from the government.
And I'm going to say, oops, 20% of your users use Google, and I'm not sure Google does that for you.
Yeah, but almost all the ISP must blocking the port 53 to the Google and everything. So all the ISP must be use their own DNS.
You'll put me in a difficult position because
No,
I
but-
know where users are that
Yeah,
use
but-
the real Google.
Okay,
Not
but
a fake
some
Google.
of them is I don't know. They just open or what happened. I also don't know. But there's a rule because every year the government will be auditing us as a ISP, as a local ISP. Are they still can use Google as a DNS server? If yes, then they will be giving the warning to the ISP.
Either a lot of warnings are going out
Yeah.
or no one's doing anything.
Yeah.
One or the other.
Well,
what can I say?
What you see in Indonesia is that a lot of ISPs announce Quad 8 and Quad 1.
No, this
inside
is the
their
real
internet.
Google
Oh, it's
because
real
I'm looking
Google
from the
you're
other
seeing,
side of
yeah.
the fence.
So that's the VPN users.
Hi, Jeff.
Hi.
Gaurav, NPIX. Do you have data, the similar data you had earlier about the latching for the Anycasted domains, like the same set of data you had earlier for the Unicast, your 4
Yeah.
servers, equivalent of that with the Anycasted?
Oh,
Because I was going to ask,
I
did you try
prepared
this
my
with
slide.
Unicast?
I prepared this slide pack in about 3 days. I was really hurried. I didn't run the script, so I'm terribly sorry.
Okay.
Data is preparable, but I didn't do it for this pack.
It would be interesting to see that because,
Yeah.
you know, when I saw your first thing, I was like, how would it look like if the 4 name servers were Anycasted?
Yeah. Anycast is hard to do yourself. And there are a few providers who can actually give you a BGP connection, a piece of metal, blah, 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 blah. And because I'm a PNIC, I've got no bloody money. And so they can do all that for free. And it's kind of, gee whiz, you really are stretching the friendship, aren't you? And it's kind of, oops, I stretched it too far.
This is very interesting, Jeff, but I promise to keep you all to your time slot. Thank you very much. This is super insightful. I look forward to our hallway track conversations. Our next speaker, Champika, pick a microphone, any microphone.
Okay, good.
Champika is from ICANN, and he is going to talk to us about multilingual internet. Take it away, Champ.
All right. Good afternoon, all. So I've been introduced. So I'll be talking about the multilingual internet. So basically talking about IDNs and EAI. All right. So we'll go through some of these topics. So the need for internationalization of domain names and email addresses. Now, as you may know, there have been a lot of work going on in IETF and a lot of other forums and so on about the internationalized domain names. Now, as you know, DNS has been there for like 40 plus years or so, right? So there have been lots of enhancements, you know, the evolution has happened over the time. Similarly, the domain names. So initially started with, you know, generic top-level domains, few of those, and then that has grown over the time. Now we have around, you know, 1,500 or so, right? So the internationalized domain names as well. So the IETF, there have been some IETF standards as well. So in 2003, the IDNA 2003 standard came, but then in 2008 also, the IDNA 2008 standard was developed as well. So that's from the IETF perspective. The EAI also has been supported. So the protocols to support the internationalized domain names also has been developed as well. So this is the sort of evolution of those. Now, first of all, you know, you have to think about the perspective, why we have to, you know, what is the main reason of defining these internationalized scripts and then how it can be represented and so on. So what you see here is the you can see the ASCII table on your left, right? So there are 127 characters that can be represented in ASCII. But then we are not using all those characters in domain names, right? So we use even though there are 127, we still use only 63 characters. So we use, those ones 0 to 9, and then A to Z, and then of course the hyphen, right? So these are used in domain names. And then the thing is that, if you have to have some localized scripts, localized characters and so on, we can't still do that in ASCII because there's no space over there, right? So that's where we have to think about other encoding schemes. So there have been some work going on, so there were Unicode encoding schemes. Even when you think of the Unicode encoding schemes, you have things like UTF-8, Unicode Transformation Format 8 bits, then UTF-16, UTF-32, and so on. So now those are some snapshots of the Unicode tables. Now all those Unicode characters, they've got what we call a code point, right? So that can be represented using this code point, right? So with Unicode, you can then have many of these different local language scripts that can be represented, right? Because currently there are about 150,000 characters in the Unicode, and then about 150 scripts that are being represented there. Now what you need to also understand is that we are not trying to get everything in the Unicode into the domain names, right? So because, for example, even if you take ASCII, as I said, even though there are 127 characters, we only get 63 of that. And similarly, even in Unicode, we have to actually decide, means the community, they have to decide which sort of characters should be there into the DNS. So this is where some work has to happen through label generation panels, what we call, right? Now there are some security implications as well when you think about these problems. So let's say if you take the label, say in Latin script, the EPIC, EPIC. So if you see these characters, the code points would be the ones that you can see over there, right? So E is 0065, and then P is 0070, and so on, right? But then we use, even if you take, say, a script like Cyrillic, you still have code points, and then, but the actual code point is different to the Latin script. So you can see that it is different. So this is a confusion, and this can be a security issue as well. In the same way, in some scripts, some more confusions can happen because, say, if you take those Chinese labels, in Chinese you have traditional Chinese, and then you have the simplified Chinese. So even though some difference with the character or the glyph, the meaning could be same, right? So still there can be some confusion over there as well. So similarly in Arabic as well, right? And Arabic again, we write from right to left. So we also have to make sure that these kind of confusions should not happen. And so this is where the variants would come into the picture. So there are things called variant labels. So we have to make sure that both these labels should not be given to two different parties, because if one party gets this, the other party gets that, there will be always confusion. So we have to have some sort of mechanism. Maybe either it should be reserved or it should be given to the same party, and so on. Okay, so this is something to be aware of. Now, so to define the script, the language rules, ICANN has been facilitating lots of these label generation panels over the years. So there have been lots of hard work, efforts have been put over the years. You can see some stats over there. So some 9 years of work And then currently there are like 17 label generation panels have been formed for different different scripts. So these are the scripts that have been integrated as well. So there are quite a lot of scripts that are in the world. Yeah, some stats out over there. So these communities, these label generation panels, they have been working because they have to define certain language rules. If you remember those early examples that I was telling, some characters could be different depending on the scripts and so on. So you have to make sure that those should not be delegated, and then the language rules and so on, right? So the community would sit in and then go through all that and define, and then based on that, the root zone labels can be delegated. So something about the label generation panels. Oops. So currently, in terms of the delegations, IDN CCTLDs altogether 63 IDN CCTLD labels have been delegated in the world for 44 economies. You can see, for example, like in India, there have been somewhere around, I think, close to about 20 or so labels have been delegated. Top-level CCTLD, top-level domains delegations have been delegated similarly to different economies in the world. And also, when you think of the generic top-level domains, there are about 90 of those has been delegated now so far. Okay, now getting more into some of the guidelines as well. Now, when you think of a domain name, there are certain rules that I said before. So we can have, in every label, we can have 63 octets. And then for top-level domains, we can only have letters. I'm talking about the ASCII here, right? And then for the second levels, we can also have letters, digits, and hyphen, right? Now for the internationalized domain names, same type of rules would apply. Similarly, for the top-level domains, we can only have the letters. Now, again, you can't really have, someone might ask, okay, why can't we have numbers and things? So if you have numbers for the top-level domains, then you can still get confused with the IP address and so on. So you'll have a IP address type label then, right, for a domain name. And then for the second levels in the IDNs, you still have the IDNA 2008. So that defines all those guidelines and rules for the labels. Okay, now there is also something that you need to be aware that is actually called Punycode. Now, when you think of from a DNS perspective, DNS, cannot process, DNS, the processing, the resolution happens in ASCII, right? So if we define those in Unicode labels, that need to be converted into an ASCII label. So this is where the Punycode comes into the picture, right? So it is basically a conversion from the Unicode label to the ASCII label. Now to identify that, there is also what we put XN hyphen hyphen. So when you have that XN hyphen hyphen, that defines a Punycode, right? So after that, what you have is the ASCII code itself. Okay. So that's what going to actually resolve in the DNS. So there are two forms now when you think of so the IDNs. So these two forms are, as I said, the Unicode labels, or what we call U labels. And then we also have the ASCII labels, or we call those as A labels. So we deal with U labels and A labels. Now, with the UTF-8, one more thing that you need to be aware as well, so this is where you have to do something called normalization in the applications, because when the user gives some input, now this, say if you take a single glyph, right, so here there is example like E with the accent. So if you consider this E with the accent, there is a code point for that, which is 00E8. And then E with the accent also can be created using the E plus the accent, right? So two different code points, which is 0065 and 0300. Now, if there are like two different inputs, this has to be normalized. So this is what, for that there is something called normalization form C or NFC. So the application has to actually, before it does the processing, it has to normalize into this NFC form. Now this all is defined in the IDNA 2008 protocol itself, right? So once you define that, so you will see the A label as well in this example as we discussed before. So you have the XN hyphen hyphen and then you have the A label, all right? So that's how the U label and A labels are being defined. So these are some examples based on those principles that what we discussed, based on those things, these are some internationalized domain names, what you see, some examples, right? So you will also notice some dots, the top level domain and the second level domain here, right? Now, going into more of the emails, so there is email address internationalization, or simply we call this as EAI. So when you think of the EAI, so what is EAI? So if you have the UTF-8 support, if you remember the UTF-8 encoding what we discussed before. So if you can support mailbox name, which is before the @ and then the domain name, which is after that sign. So using the Unicode or the UTF, then that's what we say EAI, right? But if you're talking about, say, the email subject or the email body itself and so on, the attachments and so on, here we are, that's out of scope here, right? So that's not EAI really. So EAI is basically the name, the domain name and the mailbox. All right, so when it comes to the mailbox also, there are again, some guidelines as well, because, administrator has to define the mailbox name, whether, how the mix, how that name should be generated. So in terms of mailbox, it should be in UTF-8 format. So there is no ASCII equivalent because we are talking about the mailbox itself. But for the domain name, either it can be the U label, Unicode label, or the ASCII label, the A label, right? So there are some examples here. So you can still have the mailbox in local language script and then the domain name either in the Unicode UTF-8 or in A label. So these are again, some examples to show that as well. So these are some email addresses using your local language scripts. So the how we can adapt to this. Of course, when we go through the domain name registrations and deployment, there are various steps usually we go through, right? So we have to select a domain name. So we would actually go and input our domain names, and then sometimes of course we get some suggestions for alternate domain names and so on during the registration process, and then we go through the registration, all this stuff, right? And then after that we do go through the deployment. We have to put the records into our zone files and so on, get the certificates. So there is, and then of course deploying the emails. So important thing is when you go through all these processes, if you are providing these services, tools and so on, it has to support the internationalized domain names and the email addresses. So if you find some systems that do not support that, then that need to be fixed. So this is where the universal acceptance would come into the picture, right? So basically universal acceptance is that all the domain names and the email addresses should be supported in all those applications. So when I say support means, the user input should be taken, and then it should be processed, it should be validated, it should be stored, and also it should be displayed properly as well in the application. So all those things has to happen in every of these different steps. So again, when it comes to the deployment part, specifically when it comes to the DNS, the records, records you can, you have to put it in a label in your zone files and so on, because as I mentioned earlier, the DNS do the resolution, the processing based on the ASCII, right? So you can put that A labels, and then the certificates, when you generate the certificates, we use the A labels as well. The websites, if you are providing this, make sure that it can support the UTF-8. If you are having some content management systems and so on, it should also be, you should also confine to the, comply with the IDNA 2008 standard. When it comes to, say, for example, processing the IDNs, let's say, if you type a certain IDN domain on in your browser, for example, then the application, the browser, has to convert this first. Initially it has to do that normalization first, and then after that, you will have the Punycode generated, and then the DNS query will happen based on the Punycode, right? And then you get the IP address and the usual DNS query after that. Now, when it comes to the email address internationalization, there are different levels of implementations we can see. We usually call it, first thing is, of course, there's no EAI support, which means, you can't really have any internationalized emails over there. There is also level 1 support, what we call, which means you can send and receive emails, but you still can't create mailboxes, right? Whereas level 2 means you can send and receive emails. You can also create mailboxes using internationalized email. Now, in terms of the protocols, as we know, there are MUAs, there are MTAs, and so on, right? So if you're talking about between MTAs, we have SMTP. Now, we have to make sure that the mail servers do support this. So the protocol is SMTP UTF-8. So this is what we should be expecting. So if the two mail servers are talking to each other, obviously, the sender would ask whether can you support SMTP UTF-8, and if the receiver can only support SMTP UTF-8, then only the email will be forwarded. Otherwise, it will be dropped. So we have to make sure in the path, all those mail servers in the path should support SMTP UTF-8. And in the same way, if you're talking about the MUAs, the client, either it is IMAP or the protocol that we use, should also actually comply with SMTP UTF-8. Now, a few more things to know. Case folding in IDNs, so this is automatically not supported because, unlike in ASCII, we have small case, uppercase, whereas in IDNs, we don't have that. Also, some of these spam filters and things like that, they do still filter spam based on these internationalized characters. So this should not happen, especially if you are a developer, you have to take this into consideration. Still, there are lots of services that do not support these EAI. So we have to make sure that, as I said earlier, your mail server should be able to support this SMTP UTF-8 flag. There are some studies or some, just to show you some how much of mail server support that we have at the moment. As far as 2025 is concerned, there are out of about 32 million mail servers, only about 28% of the mail servers could actually respond to the EAI mail addresses. So the internationalized email addresses. So which means we still have some 70% or so mail servers has to actually still support internationalize emails. So these are some statistics just for you to get an idea. But over the period of time, so you can see that it has been increasing. It has been doing quite good. So we still have to, in case if you are running any mail servers, make sure that you can support internationalized email addresses. I think that's what mainly I wanted to say. There are some, ICANN do facilitate something called Universal Acceptance Days. So this happens in May. So this happens annually. So if any of you are interested in actually having any UA Day events in your countries, in your locations, you can submit a proposal for 2026. Of course, the proposals have been already accepted, so it's all happening. For next year, you can still keep an eye, and if you want to actually conduct some training or some awareness events and things like that, we can support that. I think that's mainly wanted to cover. If there are any questions, can take. Otherwise, feel free to talk to me. Thank you.
All right. Thank you, Champik. We have time for half a question. All right, Kaurab.
Any of these domains in IDN?
Any? You mean any of these domains?
Yeah.
Oh, you mean no. It's. Yes. I mean, we do. Actually, ICANN internal systems, we do support that. When it comes to the ICANN.org domain, probably I should ask Kim. Kim is there over there. Do we have that in IDN?
Yes.
Yeah.
Universal avoidance, anyone? All right. Any more questions?
But we do support our systems, right? Yeah.
Thank you, Champika. That's
thank you.
so important. Right. Warren, you are the last person between these fine
Excellent.
people and a tea price.
Sweet. So if we get my slides up, I will use those ones. I'll have a timer. Excellent. So this is going to be a quick update on making local root be the default. Some disclaimers. This is joint work with Jeff Houston and Wes Hardiker and a bunch of other people. It's also still being discussed in the IETF DNSOP working group, so this is all subject to change, etc. A quick refresher on how DNS resolution works. User down here, bottom left, wants to reach a random domain.net. Web servers over there on the right. They ask their ISP asks the root says you should ask .net over there. They then ask .net, net says you should ask ns1.foo.net, blah, blah, blah. Eventually, the resolver gets an address, and then the user connects. Users are fickle. As soon as they've done that, they want to reach example.com. They ask their recursive resolver, it asks the root replies and says .com is over there, and the rest of this happens. But again, users are fickle. As soon as they've done that, they want to reach example.org. Ask the root again, root replies, blah, 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 blah. Example.id, once again, they ask the root replies, blah, 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 blah. Wouldn't it be nice if we didn't have to keep asking the root all of these questions? Right? It would be great. We could skip a whole bunch of this faff. It would be great. Luckily, there is some sort of solution for this. It's called RFC 8806, was published in 2020, and that updated 7706 from 2015. The 50,000-foot summary of that is a recursive resolver should just fetch the root zone and then store it locally, and then you don't need to ask the root. You have all of the answers already. This has a bunch of benefits. First of these is increased reliability. If you don't need to reach the root, well, you don't need to be able to reach the root. Also increased performance. The round trip time, if you don't have to send a packet, is 0. Right? There's no round trip. You don't need to send a packet. It's all great. There's also some improved privacy. Even if you're using QNAME minimization, users often mistype things like the TLD or similar. And so then you end up leaking information about what your users are trying to get to, etc. So if you don't send this to the root, you're not leaking privacy-sensitive information. There's also some parts of DOS mitigation, or at least you don't necessarily care. If somebody were to DOS the root, horribly and you couldn't reach it from where you are, you don't need to reach it. It doesn't bother you. And yeah, we're aware of 7816 and aggressive NSEC. So how do you actually do this, right? In order to be able to have the root zone locally, somehow you need to be able to get the root zone. Like, where can you possibly do this? Surely you can't just get the root zone. Turns out you can. The IANA publishes it. It's over there. Thanks, Kim. But still, what do you actually do with this, right? Now there's a root zone. How do you actually fetch it? Here's an example. You can fetch it using wget. If you were sufficiently crazy, you could have a cron job which fetches it via wget and loads it into a resolve every now and then. It's probably a really bad idea, but you know, you could do it that way. You can also fetch the root zone from a bunch of the root servers. So here is an example of fetching the root zone via AXFR from b.rootservers.net. At the moment, b.rootservers.net, c.rootservers.net, D, F, and G all make it available for AXFR. So if you want the root zone, you can just fetch it. And indeed, some people are. These are some stats from b.rootservers.net, and these are transfers by unique source address. So every day there are around 2,500 or so resolvers. We think they're resolvers. There's no way to really differentiate that from people just running dig. But there are around 2,500 people or so fetching the root zone from B. Probably these are similar numbers on the other letters. We haven't done that correlation. But, you know, this is being used. So, if you actually wanted to do this yourself, as I say, fetching it using wget's probably a bad idea. You can just configure your recursive resolver to do this. So here's the example config for ISC bind. What that says is, I would like the root zone. You should fetch it using AXFR or IXFR, and you should basically mirror the zone. So now your recursive resolver has the root zone locally, and it doesn't need to talk to the root server system to get the individual queries. Here is an example using NOT. Similar thing, I would like a copy of the root zone, fetch it using HTTP, HTTPS, and optionally, here is the TLS certificate bundle, so you use the TLS to validate the TLS connection. I'll note that this is using HTTP, wget, etc. Very similar for Unbound. Like the root zone, fetch it using HTTPS, and what these are doing is they're actually fetching the zone information and they're pre-populating the cache. So basically, now it's as though you had done all the queries. It's in the recursive resolvers cache. So, surely this is a huge amount of data. The way we figured out how much this actually is first I configured IP tables to count all of the traffic hitting the root server system. I then flushed the cache on, what did I use for this example? Unbound. So I started up with an empty Unbound instance, and I queried a name in every TLD. That forced Unbound to go off to the root, resolve the name, and it used about 1.1 megabytes of traffic transferred. If you fetch this using AXFR, so you just grab the whole zone using AXFR, it ends up being about 1.6 meg. The root zone itself is 2.3 or something, 2.2 something at the moment. The discrepancies here is interesting and took us a little bit of poking. It's less because of DNS name compression, right? Once you realize that, it seems fairly obvious, but first we're like, well, how are you, name compression. If you fetch it using wget from Internet site, using TLS, it's 2.379 meg. But these days, almost all web servers and web client libraries support gzip. So if you fetch it using, for example, I served the root zone from Nginx on one of my machines, grabbed it, and that's only 990K, because gzip compression buys you that. So there are also CDNs. These are specifically designed to do things like distribute web objects. The file of the root zone is just a web object. You can host this on a CDN. Basically, all video and web pages these days are served from CDNs, and most of the cat pictures in this presentation were substantially larger than the root zone. This is not a lot of data. These are also designed for high scalability, good geographic distribution, etc. And again, this is really not much data. If you assume there's something like 1 million recursive resolvers, seems to be roughly on the order of how many there are. And they're doing 3 lookups per day. Actually, I think I still have that in the latest slide. So why would you trust this file if you were to get it from something other than one of the root servers, or even from a root server using AXFR? Like, why would I trust this to be valid root data? That's also a solved problem. RFC 8976 is ZoneMD. What this is basically a cryptographic hash or a cryptographic signature over the entire root zone. Technically, it's a signature over a hash of the root zone, but it's basically a signature of the whole root zone. So now it doesn't really matter where you get it from. If a recursive resolver gets it via AXFR, if it grabs it from HTTPS from the internet site, if you get it from a napkin that you find on the floor, as long as you validate the signature, it could come from anywhere. Here's an example. I don't remember when this was a couple of weeks ago. But if you get the ZoneMD from the root, that is a signature of the root zone itself. Why would you do this? Oh, actually, what are we talking about in this document we're updating? So, the document we're talking about updates RFC 8806 and provides some new features. One of them is a list of places to fetch the root zone from. So instead of just saying you can fetch it from the internet or you can fetch it via AXFR, there's a plan that there'll be a list of places you can fetch the root zone from. And for each one of the entries in the list, there will also be what protocol you should use to fetch it. So AXFR, HTTPS, some other set of protocols that people might use in the future. Doesn't matter, they'll be basically the equivalent of a MIME type. There's also a document which says how you should update this list. So if somebody would like to volunteer to also help host the zone file, a procedure to be added to the list of where you could grab the root zone from. This one's also, I think, a bit more interesting. RFC 7706 and 8806 say the way that you need to implement this is you need to have an authoritative server sitting right next to your recursive server. And the recursive server asks the authoritative server, which may be on localhost, blah, blah. What the new version says is, we don't care how you do this. You should just implement it so that you're serving it, right? Implementations should figure it out. Implementers are good at this stuff. And then also some clarifications on fallback, like if you cannot update your copy of the root zone file, you should fall back to using regular DNS. Basically, that says the same thing in RFC speak. And again, why would we do this? If you don't need to reach the root, you don't need to be able to reach the root. Better performance, improved privacy, DOS mitigation, and hopefully we have a bunch of questions. I can't possibly have explained it so well that nobody has tomatoes.
Everyone is numb by the cat photos.
So I guess while we're doing this, I will see if I still have the slides on how much data. I do not. Oh yeah, I do. So if you have 1 million resolvers and you're fetching the zone 3 times a day and you're doing it uncompressed, it is 200 terabytes a month. If you did it with gzip compression, it's 80 terabytes of data per month. That is, for all intents and purposes, nothing for most large CDNs and cloud providers. Like, it's lost in the noise. So, now questions? Best idea ever? Best idea ever. Great, thank you.
So who's been doing this for the past 10 years, other than me? Cheap and cheerful. Thank you, Warren. You too can have tea.